Problem 10 from the review sheet. The physician orders a controlled analgesia of morphine sulfate, 200 milligrams in 1,000 milliliters of D5W, to be infused at a rate of 20 micrograms per kilogram per hour. The patient weighs 60 kilograms. Now remember, this is that special rate of administration of the drug that involves the patient's weight as well as time. So here we have a drug that's supposed to be spread out over time, a certain amount based upon what the patient weighs. So that's where we need to start. We need to start with the patient's weight so that we can answer the first question there, which is how many milligrams per hour will the patient receive of the prescribed drug? So we want to figure out how many milligrams per hour should this patient weighing 60 kilograms receive. So we've got the patient's weight. Now we need to bring in that special rate of administration, 20 micrograms per kilogram per hour. So now we would know how many micrograms per hour a patient this size should receive. But we want to know milligrams, so we need to move from micrograms to milligrams. And remember, that's our conversion to end up with milligrams in the numerator. We need to cancel out the micrograms, and 1 milligram is 1,000 micrograms. And now we have the units we desire, milligrams per hour. Well, let's see what simplification we can do here. 10 will go into 20 2 times. 10 would go into 1,000 100 times. 10 would go into 60 6 times. And 10 would go into 100 10 times. 2 will go into 10. 2 goes into 2 1 time. 2 goes into 10 5 times. So now it's just a matter of taking 6 and dividing by 5. 1 times 5 is 5 with a remainder of 1. 5 goes into 10 2 times. So 1.2 milligrams per hour is the correct rate of administration of this drug for a patient who weighs 60 kilograms. Well, now we want to know in part B, how many milliliters per hour? How many milliliters per hour then should we administer? Because these milligrams of drug are going to be placed into a solution in this case of D5W. So we want to know, how does this rate of administration of 1.2 milligrams per hour, how does that transfer over to milliliters per hour? So we have to have something that will get us from the solid drug to liquid. And that's the concentration information that we are given. There are 200 milligrams in the 1,000 milliliters of D5W. So we can use that information to construct a conversion fraction that will get us from milligrams to milliliters. We want to end up with milliliters, so it needs to be in the numerator, and we want to have the milligrams cancel. And the information tells us that 1,000 milliliters of the D5W is going to be containing 200 milligrams of the drug. So we can perform this arithmetic and we'll know how many milliliters per hour the patient should be receiving in the IV. Well, 200 will go into 1,000 5 times. And now it's just a matter of multiplying 5 times 1.2. And 5 times 1.2 would give us 6. 1.2 times 5, 5 times 2 is 10. 0 carry the 1, 5 times 1 is 5, and 1 is 6. Need our decimal point there because we had one digit to the right. So the correct setting of milliliters per hour for our IV equipment would be 6 milliliters per hour.